Okay, so this is practice test 4. There are 30 questions. I'm going to do non-repeated question here. In actual test, there will be only 15 questions. Okay, so let's start. First one, a baseball player swings and hits a pop fly straight up in the air to the catcher. The height of the baseball in meters, t seconds after it is hit, is given by quadratic function. How long does it take for the baseball to reach its maximum height? What is the maximum height obtained by the baseball? So the only thing you have to focus here is this is a quadratic function and we want to find out the time when that quadratic function would be maximum and the value of the maximum function. So this is a quadratic function, look like this, and at some point, at some time, you are going to get that maximum uh, height, right? And that is calculated by finding the vertex of this quadratic function. So vertex, the x-coordinate of vertex can be found by using this formula negative b over 2a. If your quadratic function is, let's say your function is ax squared plus bx plus c, this is the formula we're going to use. In our case, it's a function of time, which is negative 4.9 t squared plus 9.8 t plus 1. Negative 4.9 t squared, the function of time, function of height, a function of time, plus 9.8 t plus 1 plus 1. So if you compare this one, a equal negative 4.9 and b equal 9.8 and c equal 1, if you just plug the value of b, which is 9.8, over a is 4.9 negative, if you divide this, it will be 1. So you know uh, the maximum height will be at t equal 1, and then you can find out the maximum height by plugging the value of time in the given function. So the given height function is, remember this h and this h, they are two different things. This is just a notation we use for the formula, that's why I'm using h. Okay, find the value of this function, height function, when time is 1. That will be negative 4.9 plus 9.8. Just replace this t by 1 plus 1, which is 9.8 plus 1 is 10.8 minus 4.9. So that is what is that? Uh, that is 5.7. It's a 5.7, right? 5.7, 9, 10 point. What is that? Is that 5.7? 1? No, it's 5.9. 5.9. So 9.8 plus 1 is 10.8 minus 4.9 is 5.9. Okay, so if you go back to this problem, it takes 1 second for the baseball to reach its maximum height, and that is 5.9 meters. That's right. So basically it's about, whenever in this class, whenever you are asked to find out maximum or minimum thing, you are looking for the vertex of that quadratic function. Okay, the price P and the quantity X sold of a small flat screen television set obeys the demand equation given here, which is the price is equal to negative 0.11 x plus 286. This is 0.11. Okay, so now how much should be charged for the television set if there are 90 television sets in stock? So just put x equal 90 here and calculate the value of P, and then let me just use scientific calculator here. I'm just using scientific calculator on this website, but you are not allowed to use website while taking the test, so make sure that you use your own calculator. So that's negative 0.11 times 90, okay, plus 286. So that's the amount of the price. That's the price. Um, what should be the charge for this unit in stock? So that is 276.1. Round to the nearest cent as needed. It's already rounded to the nearest cent. So if X is 90, then price should be 276.1. What quantity will maximize the revenue? To answer this question, remember this is maximum minimum. So you have to find out the the vertex. But vertex of what? Vertex of revenue. Revenue means the price times the number of item. So P times X. The price is given, that's negative 0.1 X plus, let me go back here, plus 286. 286. 286 times X. So this is negative 0.11 X squared plus 286. As you can see that this is a quadratic function of X. So for finding the maximum value, you have to find the vertex. So the graph would be look like this. The vertex is, let's say, H and K, and then by doing the same as same thing we did in problem 1, H is negative b over 2a. If you compare this function with ax squared plus bx plus c, a means the coefficient uh, in front of x. That's a, sorry, I wrote it wrong place. Negative b is 286 divided by 2 times negative 0.11. So if you do that, um, so that is a negative time, negative divided by negative is positive, so it's a 286 divided by 2 times 0.11. I'm using this parenthesis. Make sure that when you divide, you divide it properly. If you don't use the parenthesis, that's not going to give you the right answer. So it's a 1300. So that's the maximum. That's H means that's the value of, that's X. Okay. So that's 1300. So what is the maximum value? What's the maximum revenue when X is 1300? Just plug the value of X here, which is negative 0.1 times 1300 square plus 286 times 1300. So by using your calculator, so let me see here, um, where is the calculator? So that is negative 0.11 times 1300 square and plus 286 times again 1300. So that is oh, did I use the minus? No, I did not use the minus. There should be minus. Okay, so I missed the minus here. So let me just start. Okay, what is that? I need negative sign. Negative 0.11 times 1300 square positive 286 times again 1300. Now that will give me 185,900. So what quantity will maximize the revenue? That's 1300. What is the maximum revenue? That is 185,900. So that's what we are going to write here. So maximum revenue is 185,900, and that can be the maximum revenue can be achieved by selling 1300 items. So let's go here. It's a 1300 television set you need to sell to have maximum revenue 185,000, 185,900. 185,900. So what price should be charged for the maximum revenue? So price can be found by using this formula. which is negative 0.11 times 1300 plus 286. So I'm going to use the calculator one more time. Negative 0.11 times 1300 plus 286. The price of the item should be 143. Okay, so to answer this question, as you can see that you have to know the revenue function, which is the x times p, and then from there you can find out the quadratic function, and then from there you can find out the vertex. Okay, so the next question is determine if the function is polynomial or not. To find out that thing, you just look at the exponent of x. If it's positive integer, it's always polynomial. You don't care about these coefficients. So yes, it's a polynomial because exponent of x are 6, 4 and 1, and there is a constant term. Constant term is fine. Select the correct choice. The degree of the function is the highest power of x, which is 6. um, so the leading coefficient means the coefficient of x to the power 6, which is half, and then the constant coefficient means the constant term, which is negative 2 in this case. Correct. Exactly same problem here like problem 3, so I'm going to skip it. Okay, look at the graph here, and as you can see that the in behavior of this graph both goes down and down. So the degree of this polynomial should be even, because only in the even case both end behavior goes on one side, either up up or down down. So it's even degree. Because it's going down down both sides, the coefficient, the leading coefficient has to be negative. Okay, if both of them goes to the same direction, that's even, and same direction downward, that means negatively leading coefficient. So degree should be even and it should be negative. Same problem, as you can see that the in behavior, as you can see these arrows, they are going to the opposite direction. So that means it's our degree, and if the left end goes up and right end goes down, that means it's even, as it's a negative leading coefficient. So it's a odd and then negative. Find the domain. This is the rational function. So domain can be found by looking at the denominator. So make that denominator, so think about the possibility for which that denominator would be 0. So the only value you can see here is x on the denominator. So for x equal to 0, the function would be undefined. So x equal to 0 is not possible for this function. Other than 0, any value of x would be fine. So the domain would be, you have to use the interval notation. So it's any value from left up to 0, but don't include 0, and union starting right after 0, which is parenthesis. So this symbol means anything except 0. This open parenthesis means we are not including 0, but we are going up to exactly left side of the 0. We don't know what comes exactly left to the 0, so we just use the parenthesis, and then we're going to start right after 0. So that's why we use the parenthesis. Now for finding the y-intercept, just put x equal to 0 here. That will give you the y-intercept -9. Put x equal 0 here in this function, and then the x-intercept, for x-intercept put function equal to 0 and solve for x. If you do that, here, then let me show you in this problem 7, function equals 0, that gives you the x-intercept, meaning this should be 0. And since you cannot have 0 on the denominator, so just multiply both sides by x. By doing that, you get x squared minus 9 equals 0. If you try to solve this, it will give you two different answers, x equals 3 and -3. So that's how you find x-intercept, 3 comma negative 3. Type an integer or simplified fraction, use a comma. So remember, you always have to read the instruction you have given. Oh, I got something wrong. What did I do wrong? Okay, so for finding the y-intercept, if we put 0, for finding the y-intercept, we need to put x equal to 0 in the given function. If I do that, on the denominator would be 0, but that is undefined. So that means I cannot do that. So I did mistake here. When I put x equal to 0, I thought, somehow I visualized this. I did not do it on paper, so I thought it's just a 1. But that's the mistake I was doing. You just have to plug the value x equal to 0 in the given function, and if that gives you 0 on the denominator like this, that will be undefined. That means actually there is no y-intercept. Okay, so don't do the mistake I did. I just did not do this thing in my on my paper. Just I did that problem on my head, so I missed that part. Okay, very similar question, so I'm going to skip it. Okay, vertical asymptote. So for finding the vertical asymptote, you just factor on the top, factor on the bottom. So in this case, it's already factored. So this is problem 9. It's already factored. And now after that, you just equate the bottom part 0 and solve for x. That will give you the vertical asymptote. In this case, it's x equal to negative 8. So there is a one vertical asymptote, that is x equal to negative 8. Okay, so this is very similar question, but you need to find out the factor. Here on the top, the factor is already x plus 2. On the bottom, if you try to factor out that quadratic polynomial on the bottom, that would be x minus 7 and 3. You see that 7 times 3 is 21, negative 7 and negative 3 is negative 10. So now for finding the vertical asymptote, you just have to equate this thing to 0. Remember, if you see anything common on the top and bottom, you have to cancel that before equating the 0 for finding the vertical asymptote. But there is nothing common, so just solve them and it will give you two vertical asymptote, x equal to 3 and x equal to 7. The function has two vertical asymptote, x equal to 7, that's no, x equal to 3, that's the left most asymptote, and x equal to 7, that's the rightmost asymptote. Okay, so what's the question? Find equation horizontal asymptote. For finding the horizontal asymptote, you have to compare the degree on the top and degree on the bottom. So here you can see that degree on the top is 1, the degree on the bottom is 1. So that means the horizontal asymptote can be found by if you have the same degree, let's say a x to the power m plus dot 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 dot, I don't care, b x to the power n plus dot 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 dot. If m and n, which is the degree on the top and degree on the bottom, are same, then y equal a over b is your horizontal asymptote. So the horizontal asymptote in this case, a is 5 and b is 6, so that's y equal 5 over 6 is one of the is one horizontal asymptote. Okay, next, this is again horizontal asymptote, but this time the degree on the top is greater than the degree on the bottom. So in that case, if the degree on the top is higher than degree on the bottom, then there is no horizontal asymptote. That's the rule. Okay, for finding the value of this, I already have the answer for you, that is 0.301194. Just type e to the power negative 1.2 on your calculator. In my case, it's e to the power is there negative 1.2, and that's 0.301194. very similar kind of problem, just type 5/7, so I'm going to skip it. Here we need to solve exponential equation, and whenever you are trying to solve exponential equation, make sure that if you can make the same base on both sides, then it will be easier, for solving the problem. Here on the left side you have 5 to the power half. On the right side there is a 25, so we can write down that 25 as a 5 square to make the same base. So on the left side this is 5 to the power half. The power to the power is actually times, so this is 5 to the power 2x. Now because they have the same base, so we can just equate the exponent, which is half equal 2x. Now just divide both sides by 2, so x equal 1/4. If you just have 1/2 divided by 2, that is 1/4. Okay, so x equal 1/4. Your answer should be either integer or simplified fraction. This is a simplified fraction, so we're good. So we can use the same approach here. On the left side there is a 5 to the power x minus 8. There is a 3125 on the denominator, so that 3125 can be written as 5 to the power, I don't know how many, 5 I guess. 5 times 5 is 25, times 5 is 125, times 5 is 625, times 5 is 3125. So 1 2 3 4 5. Yes, so this problem here, by using the same approach like previous problem, on the left side we can write 5 to the power x minus 8. On the right side we have 5 to the power 5, but we need to bring this base to the top, so that will be 5 to the power negative 5. So now you can equate the exponent and you can solve for x, which gives x equal 3. So x equal 3. Okay, this problem I already have the answer for this question, but I'm just going to you know um, explain you. You have a function which is a weight function that depends on time. The following function models the maximum weight W that a person can bench press in pounds at the end of T weeks of working out. Okay, complete part A through C. So first of all, what is the maximum weight that this person can be bench press initially? So just replace this T by 0, and that will be your initial means time should be 0. So in this function, find out W at 0, so that would be 250 minus 110 times e to the power negative 0.6 times 0 is 0, so it's 250 minus 110, which is basically 140 pounds. For finding what happens after 3 weeks, just replace that time t by um, 3, which is negative 0.6 times 3. You have to use your calculator properly for finding this, so I hope you know how to use your calculator. That will give you 232, and then finally if you replace this time by 6, that will give you 232. This is the approximation value. Okay, round to the nearest whole number, so this is the after rounding. And if you just replace this time by 6, that will be 247 pound after rounding to the nearest whole number. This is exactly the same problem we did before, but instead of you know weight, this case it's a number of what is that, number of bacteria. Under ideal condition, a population of E. coli bacteria, so this is the number of bacteria, can be double every 20 minutes, and this behavior can be modeled by using this exponential function. This is exponential function where t is the time in minutes, n0 is the initial number of that bacteria. Answer the following question: if the initial number of this E. coli bacteria is 5, so that means n0 is 5, how many bacteria will present in 2 hours? So just replace t by 2 and n0 by 5 and use your calculator. Second question, replace that n0 by 6 and then time by 2. Use your calculator. Third question, replace that n0 by 6 and time by 6 hours and use your calculator, and it will give you the answer. Okay, so I don't think you need me to do this problem. Just using calculator is enough. Okay, use the definition of a logarithmic function to write the exponential equation. So you have this equivalency, relation between log and exponential. If you have a to the power x equal y, or just let me just write down b to the power x as a b to the power x equal y, then I can use log base b of y is equal to x. So they are equivalent definition. You can go from exponential to log or log to exponential. So use that definition here. So if you compare b to the power x to the y, this equation, then base is 25, x is half, and y is 5. So the log definition would be log base 25 of 5 equal half. Just compare this. Look at here, 25 to the power half equal 5. So b is 25, x is half, and y is 5. So the equivalent equation is log base 25 of 5 is equal to half. So I use the very same expression. I'm going to skip it. Now from here you have to find out the logarithm without the use of calculator, and for that again we can use equivalency form. We can go from log to exponential and then solve that exponential equation. So here you can see that the base is 3, and then I'm talking about this expression. B is 3, y is fourth root of 3, and x is there is nothing, so we don't know what is x. We want to find out x. So we want to find out x, which is log base 3 of fourth root of 3. So we want to find out the value of x, so we can go to the exponential form, which is 3 to the power x equal fourth root of 3. So fourth root of 3 means it's a 3 to the power 1/4. So because they have the same base, x would be 1/4. So look at here, what is x? X is log base 3 fourth root of 3, and which should be 1/4. Okay, so it's a 1/4. Very similar question. I'm going to skip it. Find the domain. If you are finding the domain for log function, this is the log base e in this case. So whenever you have log base b, any base, we don't care, either it's base 10, base e, which is ln basically, and if there is something inside that parenthesis, for finding the domain, that something has to be greater than 0. In our case here you have log base e 5x plus 25, so that 5x plus 25 has to be greater than 0, and by solving this inequality we should be able to find out the domain. So if you just divide both sides by 5, x is greater than -5. So that's the domain for this function. But you need to write down this domain in interval notation, so it should be greater than -5. So anything greater than -5 up to infinity would be your domain. Do exactly same thing. Make this 4 minus 5x greater than 0. Solve for x. That will give you the domain. Use the property of logarithms to expand logarithm expressions. So there are product, quotient, and then power rule for the log function. So here we can use product rule because there is a log base for 16 times x. Remember, product rule means it's if there is a log base bxy, then we can write it down as a log base bx plus log base by. So here it's a log base b16 plus log base bx. Remember, 16 can be written as 4 square, right? And there is another property of log which says if there is a log base b of b to the power x, the answer should be x. So 4 base 4 base, so it should be 2 plus log base 4x. So 2 plus log base 4x, so b is your answer. Very similar type of question, but instead of using product rule, this time you have to use the quotient rule, which is log base 5 of 25 minus log base 5 of x. Log base 5 of 25 is 2, so it's a 2 minus log base 5x. You have to combine this, so we have to go back, use the properties to rewrite the expression as a single log. So it should be log base 308 divided by 4. So if you divide 108 by 4, that would be what is that, 227. So that should be log base 327, right? But what is 27? So 27 is 3 to the power 3, so it's eventually the answer is 3, right? So let me show you. This is log base 108 divided by 4 by using the quotient property, but this is 27, which is 3 to the power 3. So eventually, because they have the same base, the answer would be exponent, which is 3. Very similar kind of thing. You have to use the product rule and then power rule. You can bring this 4 to the exponent, 1/5 to the exponent, and then combine that. So it's a 28. I can write the next step would be log base 7 x to the power 4 plus log base 7 y to the power 1/5. By using the power rule, we can bring this 4 from the front to the exponent, 1/5 from the front to the exponent, and now we can use that product rule, which is x to the power 4 times y to the power 1/5, and that's all. So the answer is log base 7 x to the power 4 times y to the power 1/5. So that's the answer. Okay, we need to solve log equation because they have the same log with the same base. So what we can do is we can make 2x plus 3 equal 13. But before solving this type of problem, always check the domain of the log function you're using here. Because finally, after solving the problem, that solution should be inside the domain. So here we have the domain for the first log function on the left side. This 2x plus 3 has to be greater than 0. So 2x has to be greater than -3. If you divide both sides by 2x, should be -3/2. So any answer coming from -3/2 to infinity would be the valid answer. Now for solving this equation, we can, after finding the domain, we can accept any answer from here. Now solving this equation, we can use log base b of x equal log base b of y. If you have same log function both sides, then we can write x equal to y. So meaning in this problem, you have the same log base 5, so we can write 2x plus 3 equal 13, and if you solve for x, 2x equal 10, and then if you divide both sides by 2x equal 5, and after finding the solution, just go back and check, is it from this domain? The answer is yes, so we can write okay, x equal 5 is the answer. The final problem, as you can see, that log base 5 equal 3. One more thing, first of all, you have to check the domain. The domain, we can only take the answer, the square root of x has to be greater than 0. That means x has to be greater than 0, right? So any domain of this problem is any positive solution would be okay. So now to solve the problem, because they have the same base, we can write down absolute value, square root of x is equal to 3. If we square both sides, x would be 9. So that is from the domain, so I can write, okay, x equal to 9 is the solution. Okay, so that's practice test 4.